Hello, I'm Charlie Thompson, and welcome to the too long I didn't read the chapter version of global climate systems. So we're starting off with a lovely photograph of someplace in Alaska. Let's go over the basics. So one of the big things in this chapter is the difference between weather. Weather is the short term. It's what's happening today. It's what's going on today. As opposed to climate, climate refers to long-term averages. So 10 years averaged out or 30 years averaged out. That's the difference between weather, what it is today, and climate, looking at long-term averages. There are two main climate components that we look at when classifying climates, and in fact, just in general in climates, the two main aspects of climate are temperature patterns, which are primarily a function of latitude as modified by elevation and continentality, and then rainfall patterns, which again, primarily a product of latitude as modified by elevation in the case of orographic lifting mechanisms. So places in the mountains are colder, places on the windward side of mountains tend to be rainier. This is a map of mean or average temperature. So you can see the difference between the tropics, where it's really, really warm, and then the high latitude areas, the subarctic and Arctic regions are much colder. So it's primarily latitude as modified by elevation. So the Tibetan Plateau, it's high and cold. Here's the Alps, those are high and cold. The Ethiopian highlands, a little bit of highland climates right there. You can see the Andes, the higher elevation making them colder. You can see the Rockies, the Sierra Nevada, the Appalachian Mountains. So the overall patterns to temperature for average temperature, latitude, again, the most important factor. Latitude is modified by elevation. And then when we look at temperature range, it's going to be, again, latitude. Lowest ranges are in the tropics. As you move away from the tropics, the temperature range gets higher and higher and higher. As you move inland, the temperature range gets higher and higher as you move inland. You'll notice that there's no yellow spots in the entire southern hemisphere. So very low, much lower temperature ranges in the southern hemisphere. On this map, here's the equator, the Tropic of Cancer, the Arctic Circle, and the Antarctic Circle. You can see, so this would be 23, this would be about, I guess these are every 20 degrees, so that would be 20 degrees. That'd be 40 degrees south. At 40 degrees south, there's just like a little bit of South America, kind of misses Tasmania. There's between 40 and 60 degrees south, there's hardly anything at all. So between 40 and 60 degrees south, you've got major land masses in North America. In the southern hemisphere, you got nothing. And then rainfall patterns, again, function primarily of latitude. The ITCZ, I'm going to talk about that in just a minute. The ITCZ is incredibly important. The polar front, warm currents, so they have year-round rainfall. You can see they're darker blue, year-round rainfall, year-round rainfall, year-round rainfall on the East Coast. On the West Coast, they're going to have a drought in the summer, drought in the summer, drought in the summer, drought in the summer, and in the Mediterranean, a drought in the summer. So for the most part, for climate classification, the most important factor is just going to be latitude as modified by elevation and continentality. So I wanted to talk about the shifting ITCZ, the shifting subtropical highs, and how those create the tropical and some of the mesothermal climates. So if we start playing this, you can see the ITCZ. It is wintertime because the ITCZ has shifted south. This is going to create dry conditions across South Asia with high pressure because it's wintertime in Siberia, so the air is going to be blowing offshore down towards the ITCZ. And as the year starts to progress, we're going to see the ITCZ start to shift north. There it goes. It's going north. And so now we've got rainy conditions in the summertime. We've got rainy conditions. The subtropical high is beefy. now that it's June, end of June, beginning of July. Subtropical high is blocking the storms for the west coast of the United States. There's high pressure here, but the way the high pressure is going to move, it's actually going to blow air over the ocean, which is going to pick up moisture and then go inland, get lifted up, and make thunderstorms in the summertime on the east coast. As we move into fall, you can see the ITCZ is shifting south. The subsolar point is moving south, so now the Hawaiian high drops out of the way. The Aleutian low picks up strength, and so storms track into the west coast of the United States. The ITCZ has shifted south, so again there's high pressure, drought conditions with the monsoonal climates, and rainy conditions in the mid-latitudes. All right, so going from winter conditions into summer conditions, what I'd like you to pay attention to is the idea that the ITCZ isn't just a narrow band of precip, it's a really broad area with lots and lots of rain. And so as the ITCZ shifts north and south across Africa, across South America, there are some places that are just going to catch the edge of the ITCZ during one season. And then as the ITCZ starts to shift back south, they're going to have drought conditions. And now there's parts down here that are going to get rain, parts down here that are going to get rain. But there's going to be a zone in the middle that's going to be lucky enough to get rain more or less year round. That's where the rainforests are going to be. So the rainforests are in the region where the ITCZ is going to be overhead year round. And as you get away from the as you get away from the ITCZ, you'll bump into the subtropical high, and you're going to go from rainforest to monsoon to savanna into steppe and then full desert. Out of the desert, you're going to run into steppe and then Mediterranean and then marine west coast and other mesothermal climates. So if we look at the components, the actual factors that cause climate, the most important driver of climate is energy from the sun. So insolation, it's just a function of latitude. That creates Earth's energy balance with a surplus in the tropics and a deficit in the poles. So heat energy is constantly flowing from the equator to the tropics to the poles. Temperature, function of latitude. Air masses, a function of latitude and continentality. Air masses that form over the ocean are wetter than air masses that form over the land. Air pressure, primarily a function of latitude with the ITCZ, with low pressure around the equator, high pressure in the subtropics, low pressure in the mid-latitudes, and then high pressure at the poles. So the high pressure locations have lower rainfall, the low pressure have higher rainfall. Atmospheric moisture and precip, that's just going to be a function again of air pressure, air masses, temperature, and lifting mechanisms. So it's primarily latitude as modified by mountains in the case of orographic lifting. And here we have the 5 climates that Vladimir Kirpin originally divided climates into. We have the tropical, dry, mesothermal, microthermal, and polar climates. So the tropical climates, the mesothermal, microthermal, and polar climates are defined by temperature patterns. The dry climates are the only ones that are defined by water balance. So let's break it down and go through each of these general climate groupings one by one. The first, tropical. The definition, the main characteristics of tropical climates, in fact, everything but the dry climates are going to be defined first. The category, the criteria for the category is pretty much going to be temperature. So with the tropical climates, they have no chill. Every month is above 18 Celsius on average. That's about 64 degrees. So in the tropics, every month the average temperature is above 64 degrees. If there is a month where the average temperature is below 18 Celsius, it can't be a tropical climate. The dry climates are defined by a moisture deficit. There's 2 types of dry climates. There's deserts and steppe. I'll go into the differences in the longer video, but the defining characteristic of the dry climates is that they have an annual moisture deficit. Mesothermal. Meso means middle, thermal means heat. These are temperatures, these are climates that have a summer, 3 months over 10 Celsius, which is 50 Fahrenheit, and a winter that is above freezing. The book refers to mild winters, and instead of mild winters, every time you see the word mild winters in the book, just think, oh, that means that it's above freezing. The coldest month in the winter is above freezing. So they have a winter time, but the average temperature is above freezing, and they have a definite summer with 3 months above 10 Celsius, and that's because you need 3 months over 10 Celsius to get good tree growth. So one of the criteria for the mesothermal climates is you have to have conditions for good tree growth, both in terms of water, because it's not a dry climate, and in terms of temperature. Going towards the poles, you end up with microthermal climates, small thermal heat. So think of these as cold or snowy forest. One of my favorite adjectives or favorite terms to describe the microthermal climates is snowy forest climates. So they still have a summer with 3 months over 10 Celsius, but the winter is below freezing. So they have a huge swing in temperatures from summer to winter, and the main defining characteristic of the microthermal climates is that they've got 3 months of summertime, but the winter is below freezing. And then finally, we have the polar climates. Every month is below 10 Celsius. And again, that's about trees. You might think that the criteria for the polar climates should be every month below freezing, and there is a climate, the ice cap climate, where every month is below freezing. It's a type of polar climate. But the general classification criteria for polar climates is every month is below 10 Celsius. So if we look at a map of tropical climates, you can see there's 3 different types of tropical climates. I'll talk about those, but they're all pretty much in the tropics. The defining characteristic of the tropical climates is every month is warmer than 18 degrees. As you move away from the tropics, where air is rising with the Hadley cells, it sinks and it forms the dry climates. So we have desert and steppe, desert and steppe. Most of the deserts have a core of desert, and then they have a ring of different types of steppe climate around them. So this red is desert, this tan is a steppe. It's a dry climate, but it's not as dry as a desert. So as we move from the tropical climates to the dry climates, the next step is going to be the mesothermal climates. They have a summertime, they have a wintertime. There's the East Coast climates where they rain year-round. There's the Mediterranean climates where there's a summer drought. I'll go into the 4 different types of mesothermal climates in the longer video. As we continue to move away from the equator, we're going to end up in the microthermal climates. So these are even farther away from the equator, closer to the poles than the mesothermal. They still have a summertime, but now we have freezing winters. So these are the climates of the northern Eurasian countries, the climates of the far north parts of the United States, especially on the East Coast, and then up into Canada. You'll notice there are no microthermal climates in the southern hemisphere because there's no landmass that's big enough at the right latitude to create the temperature swings that you need to make a microthermal climate. To make a microthermal climate, remember, you need to have warm summers and freezing winters, and the only way you can get that is as a result of high latitude and high continentality, and there just isn't a landmass that meets those criteria in the southern hemisphere. The polar climates, they're at the poles. It's cold, it's cold, it's cold. Antarctica, polar. Greenland, polar. Parts of Iceland, polar. Parts of Canada, polar. These technically aren't polar climates. This would be the Andes, also the Rockies, also parts of the Sierra Nevada, the Tibetan Plateau. Those are classified as highland climates. I'll talk more about highland climates in the longer video, but the true polar climates are at polar latitudes. This isn't at a polar latitude, so it's a highland climate. This isn't at a polar latitude, so it's a highland climate. And here we have them all together. And as you go from the tropics, you have the tropical climates. And as you work your way from the tropics to the poles, it goes from tropical to dry to mesothermal to microthermal and then polar. Here's the map in the book. The map in the book lists, these are the individual climates. I'm not going to make you learn most of them. You need to know the 3 tropical, the 2 dry, the 4 mesothermal, 2 microthermal, and then polar. And the nice thing about this map is it includes not only the distribution of the various climates, but also the causal factors. So you can see cold currents off the west coast, warm currents off the east coast. You can see the shifting ITCZ going north and south in January and north in July. You can see the effect of not just the ITCZ, but the subtropical high, and then up here, these lows, that would be the polar front. So you can see how that's going to affect climates as well. Again, here's all the different climate types that we'll talk about. You don't need to know them all, just the 3 tropical, the desert and steppe for the dry climates, 4 mesothermal, humid continental and subarctic for the microthermal, and then I'm just going to lump all the polar climates in as polar climates. I've also included at the very end of the chapter slides, a hypothetical planet. This is kind of an interesting idea. I don't remember where I stole this from, but I've also included in the announcements a link to a website for fantasy and science fiction writers about how to make the climates on your planet believable. One of the things that always pissed me off about Game of Thrones was the continents were just too small to have the range of climates that they had in Westeros. Physically, it wouldn't have worked. I have no problem with dragons and magic, but don't get your physical geography wrong. So over here we've got cold currents on the west coast, warm currents on the east coast. We've got the ITCZ, the subtropical high, the polar front, and then the polar highs. So you've got tropics in the tropical climates in the tropics, followed by the desert and steppe climates. And then we have some of the mesothermal. This would be like marine west coast, Mediterranean, humid subtropical. And then we're going to get up into the continental climates, and finally the polar climates. And this is another, here it is. I've even included the link to the site on Stack Exchange about how to build climates on a hypothetical planet. You can see the distribution on these is pretty similar. So it might be fun for you to compare the hypothetical map with the map in your book to see how it compares with tropical rainforest around the equator. Slightly higher because you've got a warm current over here, so there'd be more water vapor. Narrower band over here with the cold current. Deserts with the cold current and the high pressure. On the east coast, for example, the United States, you've got humid subtropical. Then you have a microthermal climate, the humid continental, and then you're up into the polar climates. On the west coast, Mediterranean gives way to marine west coast, and then gives way to tundra and ice cap. So take a look at that. Take a look at the world building article. You might enjoy it. And that's it for now. Good luck with learning climates.